the ocean floor, and the slow shape of Earth. Welcome to the Sleepy Archive. Tonight, we find ourselves at the edge of a great, quiet threshold. We are looking out across the surface of the world's oceans, a vast, rhythmic expanse that covers more than 70% of our planet. It is a place of constant, gentle motion, where the air meets the water in a ceaseless exchange of mist and salt. Before we begin our journey into the depths, please take a moment to settle into a position of total comfort. Adjust your blankets, let your shoulders drop, and allow your breathing to find its own natural, easy pace. In a few moments, the images on your screen will begin to fade, transitioning slowly and softly into darkness. This is intentional. The visual world will recede so that your mind may drift more freely, guided only by the sound of my voice and the steady, ancient story of the Earth beneath the waves. As the light grows dim, imagine the surface of the water becoming still, like a mirror reflecting the evening sky. We are here to explore the silent places, the hidden landscapes that lie miles below the keel of any ship. We are here to witness the slow, patient shaping of our world, a process that takes place over millions of years, far removed from the hurried pace of our daily lives. The darkness is a blanket, a space for rest, and a gateway to the deep. The silent weight of water. As we leave the surface behind, we enter a world defined by a different kind of time. In the upper layers of the ocean, there is still the play of light flecks of gold and turquoise that dance in the wake of the waves. But as we descend, the sun begins to lose its strength. The bright yellows and reds are the first to go, filtered out by the density of the water. The world turns a deep, bruised purple, then a heavy indigo, and finally, a velvet black. This transition is not a sudden event. It is a gradual surrender. The weight of the water above us increases with every foot we travel downward, but it is a weight that feels like a support, a consistent pressure that holds everything in a state of suspension. In the deep ocean, there is no wind. There are no storms. There is only the slow, massive movement of currents that travel like rivers through the dark, carrying cold water from the poles toward the equator. These currents move with a majestic indifference to the world above. They are the circulatory system of the planet, moving nutrients and oxygen in a cycle that takes 1,000 years to complete. To be in the deep ocean is to be inside a great liquid clock, one that ticks not in seconds, but in centuries. The lead line and the patience of discovery. For most of human history, the bottom of the ocean was a complete mystery. It was thought to be a featureless plain of sand, or perhaps an abyss without any bottom at all. In the 19th century, the only way to measure the depth was with a lead line, a long, heavy rope with a weight at the end. Imagine the patience required for such a task. A ship would come to a complete stop in the middle of the Atlantic. Sailors would heave a lead weight over the side and watch as the rope unspooled, foot by foot, fathom by fathom. It could take hours for the weight to reach the bottom, and hours more to haul the rope back in. Sometimes, the currents would pull the line at an angle, making the measurement uncertain. Yet, through this slow and repetitive labor, the first true map of the ocean floor began to emerge. It was a map made of single points of data, connected by long stretches of imagination. These early explorers were like people feeling their way through a dark room with a single finger. They found that the ocean was not a flat basin. They found mountains where they expected plains, and deep gashes where they expected plateaus. They began to realize that the earth beneath the water was just as complex, just as varied, and just as ancient as the land they walked upon. The voyage of the HMS Challenger in December of 1872, a converted warship named the HMS Challenger set sail from Portsmouth, England, on a voyage that would change our understanding of the planet forever. The Challenger was not looking for new lands or gold. It was looking for knowledge. For nearly 4 years, the ship traveled almost 70,000 nautical miles, crisscrossing the globe's oceans. The scientists on board were equipped with miles of Italian hemp rope and hundreds of thermometers protected by thick glass. They performed hundreds of stations where they would stop the ship to take soundings, dredge the bottom for samples, and measure the temperature at various depths. This was science at its most rhythmic and meditative. The sound of the steam winch, the dripping of the wet rope, the careful cataloging of tiny shells, and multicolored mud, this was the pulse of the expedition. They discovered thousands of new species of life, creatures that lived in total darkness under immense pressure. But more importantly, they confirmed that the ocean floor was a dynamic landscape. They discovered the existence of the Mid-Atlantic Ridge, though they did not yet understand what it was. They proved that the deep sea was not a wasteland, but a vast, silent archive of the Earth's history, waiting to be read. The continental shelf and the long descent. If we were to walk away from the shore, we would first traverse the continental shelf. This is the submerged fringe of the continents, a relatively shallow area that teems with life. Here, the sunlight still reaches the bottom, and the water is influenced by the tides and the weather. But eventually, we reach the shelf break. The ground begins to tilt more steeply downward, forming the continental slope. This is the true edge of the world we know. The slope is often scarred by massive underwater canyons, carved out by ancient rivers, or by the slow, underwater avalanches of silt and sand known as turbidity currents. These canyons are grander than anything found on land, with walls that rise thousands of feet into the gloom. As we descend the slope, the pressure increases and the temperature drops. The water becomes a steady, unchanging 4 degrees Celsius. This is the realm of the continental rise, a gentle apron of sediment that has tumbled down from the shelf over millions of years. It is a soft landscape, a place of accumulation. Everything that washes off the land eventually finds its way here, settling into a thick, quiet blanket that smooths out the jagged bones of the tectonic plates. the abyssal plains and the fall of marine snow. Beyond the continental rise lie the abyssal plains. These are among the flattest and most level places on Earth. They cover vast areas of the ocean floor, lying 3 to 4 miles beneath the surface. To look upon an abyssal plain is to see a landscape of absolute stillness. The soil here is a fine, soft ooze made of the remains of microscopic organisms that have drifted down from the sunlit waters far above. This constant, gentle drift is known as marine snow. It consists of tiny shells, flecks of organic matter, and dust from the atmosphere. It falls day and night, century after century, a slow-motion blizzard that never ends. In some places, this layer of sediment is miles thick, burying entire mountain ranges beneath a shroud of biological dust. The animals that live here move with a slow, deliberate grace. Sea cucumbers creep across the mud, leaving faint trails like those of a finger in flour. Tripod fish stand perfectly still on their long, elongated fins, waiting for a passing morsel to drift into their reach. There is no urgency here. In the abyssal plains, a single footprint could last for 1,000 years, undisturbed by the currents of time. The mid-ocean ridge and the breath of the earth. In the center of the great oceans, the floor begins to rise again, but not into a continental shelf. Instead, we find the mid-ocean ridge, the longest mountain range on Earth. It is a continuous chain of volcanic peaks that winds around the globe like the seam on a baseball. But this is not a range formed by the folding of crust like the Alps or the Himalayas. The mid-ocean ridge is where the Earth is pulling itself apart. Along the center of the ridge lies a rift valley, a place where the tectonic plates are slowly diverging. From deep within the mantle, molten rock magma rises up to fill the gap. When it hits the cold seawater, it hardens into new crust. This is the process of seafloor spreading. The Earth is constantly creating new skin in these dark, volcanic valleys. It is a quiet, persistent labor. The plates move apart at about the rate your fingernails grow, a few centimeters a year. But over the course of geological time, this slow expansion has pushed continents across the globe and opened up entire ocean basins. The mid-ocean ridge is the breathing heart of the planet, a place of constant renewal and silent tectonic power. Marie Tharp and the Valley of Truth, the realization that the mid-ocean ridge existed and that it had a rift valley at its center, was one of the greatest scientific breakthroughs of the 20th century. But the person who first saw it was not allowed to go to sea. Marie Tharp was a cartographer and geologist who worked at Columbia University in the 1950s. While her male colleagues were out on research vessels collecting sounding data, Marie stayed in the office, meticulously plotting thousands of depth measurements by hand. She was looking for patterns in the noise. As she drew the profiles of the Atlantic floor, she noticed a consistent V-shaped notch at the top of the central mountain range. She suggested it was a rift valley, evidence that the seafloor was spreading. At the time, the idea of continental drift was dismissed as scientific heresy. Her own colleague called called her observation girl talk. But Marie persisted. She spent years refining her maps, connecting the dots of light and shadow. Eventually, when the data from earthquake epicenters was overlaid on her maps, it was clear that the quakes lined up perfectly with her Rift Valley. The evidence was undeniable. Marie Tharp's hand-drawn maps revealed the true face of the ocean floor, proving that the Earth was a dynamic, moving puzzle. Her work transformed our understanding of the planet from a static rock into a living, shifting system. The inner light of the deep, in the true abyss, where no sunlight has ever reached, the inhabitants have created their own light. This is bioluminescence, a soft, chemical glow that flickers in the darkness. It is not the harsh light of a lamp, but a gentle, pulsing radiance, blues, greens, and sometimes pale yellows. For the creatures of the deep, light is a language. Some use it to lure prey, like the anglerfish with its glowing lure. Others use it to startle predators or to find mates in the vast, empty volume of the sea. Imagine drifting through the midwater zone, miles below the surface. You would see tiny sparks and glowing clouds, like stars in a midnight sky. Some jellies trail long, luminous tentacles like ribbons of neon. Small crustaceans fire off clouds of glowing chemicals to mask their escape. This light is cold. It produces no heat, only information. It is a reminder that even in the most remote and hostile environments, life finds a way to express itself with beauty and ingenuity. The bioluminescence of the deep sea is the Earth's most private light show, performed for an audience of none, in a theater of eternal silence. The quiet hearth of the hydrothermal vents. In the 1970s, scientists exploring the mid-ocean ridge discovered something they never expected: life that did not depend on the sun. Deep in the rift valleys, they found hydrothermal vents, underwater geysers where superheated water, rich in minerals, spews out from the crust. These vents are surrounded by lush communities of giant tube worms, white crabs, and ghost-like fish. In a world of near-freezing water, these vents are islands of warmth. But the most remarkable thing is their energy source. Instead of photosynthesis, which uses sunlight, the bacteria at the base of this food chain use chemosynthesis. They turn the chemicals from the vents, hydrogen sulfide and methane, into food. This discovery upended our definition of where life could exist. It suggested that life might thrive on icy moons or distant planets, far from any star. These vent communities are ephemeral. They last for a few decades, until the volcanic plumbing shifts and the heat disappears. Then the animals must find a new vent, drifting as larvae through the dark, until they sense the chemical warmth of another hearth. It is a fragile, beautiful cycle of life, fueled by the internal heat of the earth itself. The Mariana Trench and the softest shadows, the final frontier of the ocean floor, is the hadal zone, the deep trenches that mark the places where the ocean floor is being destroyed. These are the deepest gashes in the Earth's crust, formed where one tectonic plate is being forced beneath another. The most famous is the Mariana Trench in the Western Pacific. At its deepest point, the Challenger Deep, the bottom is nearly 7 miles down. If you were to drop Mount Everest into the trench, its peak would still be covered by more than a mile of water. The pressure at the bottom is immense, over 8 tons per square inch. It is a pressure so great that it would crush a modern submarine like a soda can. Yet, even here, in the ultimate shadows, there is life. Small, translucent amphipods and pale, delicate snailfish inhabit these depths. The bottom of the trench is not a jagged rock, but a soft, fine mud settled there by gravity over eons. It is a place of absolute stillness. The water here is very still, and the silence is complete. To be at the bottom of the trench is to be at the very limit of the terrestrial world, a place where the weight of the entire ocean feels like a heavy, protective blanket. The archive of sediment and the long memory, the ocean floor, is the Earth's great historian. While the landscapes of the continents are constantly eroded by wind, rain, and ice, the deep ocean floor is a place of preservation. The layers of sediment, the marine snow we discussed earlier, are like the pages of a book. By drilling deep into these layers, scientists can read the history of the planet's climate. They can find the dust from ancient volcanic eruptions, the chemical signatures of past ice ages, and the microscopic remains of organisms that lived millions of years ago. The mud tells the story of the birth and death of oceans. It records the slow drift of the magnetic poles, which flip every few 100,000 years, leaving a magnetic stripe in the hardening lava of the mid-ocean ridge. The ocean floor remembers everything. It remembers the impact of the asteroid that ended the age of the dinosaurs. It remembers the gradual cooling of the Earth as the continents moved into their current positions. It is a slow, patient archive, accumulating its data grain by grain, shell by shell. The slow shape of the Earth. As we return our thoughts to the surface, we carry with us a new understanding of the world's shape. The Earth is not a static ball of rock. It is a slow-motion kaleidoscope. Under the oceans, the crust is constantly being born at the ridges and consumed at the trenches. The continents are like rafts of lighter rock, drifting on a sea of denser mantle, pushed and pulled by the hidden machinery of the deep. This process is so slow that it is invisible to us, yet it is the most powerful force on the planet. It builds mountains, opens oceans, and creates the very atmosphere we breathe. The stillness we feel when we think of the ocean floor is the stillness of immense power held in balance. It is a reminder that the most important changes in our world do not happen with a bang, but with a quiet, persistent pressure. The Earth is shaping itself, day by day, century by century, in the dark and the cold, with a patience that exceeds our comprehension. The unending peace. Now, let the images of the deep ocean floor begin to fade from your mind. Imagine the soft mud of the abyssal plains, the gentle drift of the marine snow, and the steady, rhythmic pulse of the mid-ocean rift. These places exist right now, miles beneath the waves, in a state of eternal, undisturbed peace. The pressure is a comfort, The darkness is a sanctuary, and the cold is a steady, unchanging presence. You are safe. You are supported. The world is vast and ancient, and it is taking care of itself in the most patient way possible. Feel the weight of your own body against the bed, a reflection of the heavy, peaceful water of the deep. Let your breath remain slow and easy. There is nothing you need to do, nowhere you need to go. The story of the earth is long, and you are a part of its quiet, unfolding history. Sleep now, and let the slow shape of the world carry you into a deep and restful silence. The archive is closed for the night, and the ocean is still. Good night.